Hey everyone, welcome back to the workshop, and today I am excited to take a look at the Atomstack X40 Max. This is a 48 watt diode laser that is 800 by 400. However, the cool thing on this one is 800 wide and 400 deep. Gives me the orientation and the size to really work with the material for my model airplane hobby, as well as creating all sorts of things that I do in the shop. So I'm gonna stop yakking, we're gonna jump right into it. Stay tuned, and here we go. So I'm just going to really quickly show you the unboxing experience. This does come in a rather long box and does pack really well with foam. You'll see this does have those longer rails, as this is an 800 millimeter wide, or about 31.5 inch working area. So we're going to get all the parts separated out of the foam, checking to make sure everything's okay, making everything in order for our build, and then we'll jump into that next. So the build went pretty well. I didn't run into any issues. Did make sure to adjust the concentric wheels as they come fairly tight, and they might have a little bit of a divot in them from being compressed so long, but you want to let those kind of run out. So do take some care to double check that all those things are adjusted to the proper fit, your belts are the right tension as well, and then also just kind of keep an eye on any of the bolts that are pre-installed, such as on the head. Make sure you go through and tighten those up. That's going to make sure everything's running as tight, as smooth as possible. Outside of that, everything went pretty smooth. It's a typical Atomstack build with their frame and the extrusions. No real surprises there. Some of the features I really like on this one, of course, we have an emergency stop button on here. I always like to see physical emergency stop button on the lasers. There are just times when things are going wrong, you want to kill everything. It's great to have those on there. So they do have these here. However, one of the cons is these cables are sticking up out of the top still. They do have some coming off the side that go to the wiring for the rest of it. Now, the air pump, it would just be nice to see this power and USB off to the side to get them out of the way of that emergency stop button. But that's more of a nicety than a criticality to have, so I'll just leave it there. I do really love seeing the cable chain on both axes. It helps keep those cables managed, keeps them out of the way. I did on this side one zip tie it down so that the wire loom wasn't sliding around in there. Just felt like that maybe have caused a little bit of a varying pressure on the axis. And then of course they labeled the cables pretty well. They're easy to plug in, but I would like to see maybe just a few mount points. They do provide some zip ties, but it'd be nice to have a spot here to anchor this down. I'll probably be putting on some sort of like stick-on zip tie hold point there, just to keep these cables from, you don't want them to rub on the side or anything and get frayed out. But other than that, the cable management and the hose management is really good on here. Everything's routed, nothing's gonna drag across the surface. It keeps it out of the way and works well. The focus adjustment is this kind of thin knob up on top. It works pretty well. And then they, of course, include the step-down block. This is for your focusing. You've got a cutting level and an engraving level. And then, of course, if you take this shroud off, which you can, then you just stand this on end, and that should also be your focus distance for, I believe, engraving. Cutting, you might want to bring it down just a little bit if you have thicker material and such. But overall, it seems to work pretty well. You don't have knobs and aren't having to physically adjust this. It's some nice kind of fine tuning. It's loose, so it's easy to spin, but it doesn't feel like it's going to move while it's in operation. Another nice upgrade you'll see on this one over previous Atomstack machines is the linear rail on the X-axis. Definitely nice to see that on there. You are going to want to keep that clean. You're going to want to keep that lubricated with a little bit of light machine oil and such. It's great on these longer distances. I think it keeps things tighter and relies less on those wheels that will wear down over time. Outside of that, it does have the included air pump that is wired into the controller, so you can use your light burn switches to turn on and off the air. And then it does have the knob on top that gives you your variable speed. And this is one of my favorite air pumps that I've seen across all brands. It is a high power pump, seems to put out a lot of air, has the variable speed knob on there, and just generally works really well. Of course, you're going to need a big honeycomb for a cutting surface on this, and you'll need an enclosure. I have kind of rigged up a bit of a temporary enclosure out of some model airplane foam here. This cuts down on the smoke, but it doesn't contain it fully. So I'll definitely be building something bigger for this in the near future. I just didn't get it done and wanted to get this review out for you all. So this, I don't recommend you do. It's just for me at a pinch to be able to do some testing and get a real layout for this laser before I build its enclosure. So with all that, let's get to the testing. So one of the things I really enjoy using on my lasers is 3mm Baltic birch plywood. It's a little bit harder than your typical craft plywood, but as far as some durability and strength, sometimes when I'm doing three-dimensional items, I want a little more rigidity to it, and this fits the bill. It's become a little bit harder to find in recent years, although it's easing up, but the price has gone up a bit, so you may want to factor that into it. But I've been using these tests for a while, so I continue to do them. So if you look back at any of my other tests, you'll be able to see some comparisons. So as I said, I started out with this 3mm Baltic birch, and I run cut tests. And I like to run it more than once. Just want to kind of getting started with this laser, we dial in and make sure that we're everything's set up right and the airflow is going right and we're getting consistent results. And we are. So on this one, it was really topping out at 800 millimeters a minute at 100% power. And those were kind of the clean dropouts, or maybe just a tiny little fiber holding it on. And you can see it pretty decent as you get up into those upper levels where it's not cutting through as much. You're starting to get a little bit of that smoke debris coming through, but on the bottom ones, just a little bit of a touch of the start spot where you see a little bit of burn. Otherwise, it's coming through to the bottom, and I'll show you the backside here. I've not done anything to clean these up. But that is how they're going through. And you can see even at those higher powers, there's trying to peek through, but there's just too many fibers that you would have to push through and clean up. But overall, for a 40-ish watt laser, not too bad. Again, considering this is a more dense material than your typical craft plywood would be. So seeing that I was getting a pretty good gradient here and pretty consistent results, I was happy with that and went ahead and moved on to other materials. So this is close to 1/8 inch material. This is some Home Depot hobby pack. I think it's about 3.18. It's closer to 1/8 inch material. This has more of a light duty core and then veneers of birch on the outside, both sides. So here is that same cut test, and we're squeaking out just a little bit faster due to the softer nature of the core. We're getting at 900 millimeters a minute. At 100% power, and then also getting through at 800 at both 90 and 100. So there again, very similar material, but slightly different, gives you a little bit better results. And still again, cutting fairly consistently, fairly clean. The backside definitely not really having any extra smoke and markings there. So that's a good mixture between the honeycomb and the air assist working very well. And getting some nice speeds out of this material. So then I went ahead and stepped it up to the 1/4 inch variety of this same material. This is, again, stuff from Home Depot. It has kind of a thin veneer layer, if I can show you that, top and bottom, and then an MDF core in the middle. So with this one, a little bit slower, but for close to 1/4 inch material, doing pretty well. We're just squeaking out 700 millimeters a minute at 100% power. And once again, I'll show you the backside. We're getting pretty clean cuts. Some of those bottom ones, they're just almost wanting to come out, but just kind of holding on by some fibers. And so decent rating for that as far as being able to get through at some higher speeds. A lot of times when I'm cutting this 1/4 inch material on some of the 20 and 30 watt lasers, I'm down around maybe 400 to 600 millimeters a minute. And so we're gaining a little bit on this one, getting up there in that 40 to 48 watt power. So after that, I wanted to do some tests with cutting thicker materials and wanted to see what we could get through. And so I took this 3/4 inch poplar and just ran some tests. I started out at 100 millimeters a minute and 100% power, just drew basically a 1-inch circle, ran through there, ended up going all the way up to 175 millimeters a minute. Again, 100% power, and it did cut through there. So hopefully I'm showing you on the video overlay how that looks. The cuts were clean, and then here is the 175 millimeters, and you can see it is not really charred, it's caramelized, but you're not seeing like real deep charcoal like leave marks on your fingers kind of stuff. So really impressed, able to get through this. So that's about 19 millimeters, 19.5 millimeters of thickness, decent capability at, you could get through this. Now, of course, that's not fast, but the fact that it can cut through this thicker material is definitely going to open up some options for you as well. Now, with cutting, I did want to go back and check on craft plywood. So I did run a test on the craft plywood, and here's what we came up with. We were definitely getting through this a lot faster. This is 3 millimeter or 1/8 inch material, and we're blasting through this at 1,000 millimeters a minute, even at 80% power. And I'm pretty sure I could bump this up, probably squeak out 11, maybe 1,200 millimeters a minute. But at that speed, I was pretty happy, and I like to give myself a little bit of variance. Sometimes you run into various pockets and glues in these materials. So I'm generally going to run it at about 80% anyway. So knowing that it can cut through this still at that power and get through cleanly was good. But with that, I also wanted to see, what does our kerf look like? And so the kerf is the amount of material that is blasted away when you're cutting through with any material. I mean, it's kerf of a saw blade generally is the thickness of the saw blade. Well, with this, you're using a beam of light, and it's hard to measure that. So what I do is I end up drawing 4 squares here, and these are all 30 millimeter squares. And then what I do is I cut them out in series just to make sure we get a law of averages, make sure one's not off. And then I measure both the inside and the outside dimensions, and then of both the object as well as the cutout. And that gives you basically what's left. So obviously when we're measuring both sides, we got to divide that in half because there's a line on each side, and that will give us our kerf. And so what I came up with this one is that we had an overall thickness of 0.27 millimeters in the x-axis and a 0.29 millimeters in the y-axis. So that's pretty decent and fairly close to each other. There's a slight variance, and you'll find that with these diode lasers, is that the beam is actually more rectangular, sometimes square, but it's definitely not round. And so if we're thinking in the terms of kerf, if your laser is following a line, your beam is going to be cut in half. Half of that beam is going to be on the inside and half of it's going to be on the outside. So if you're trying to look at what you'd need to subtract for this, for your kerf cuts, you're going to be somewhere between 0.135 and 0.145 millimeter. Again, for a 40+ watt diode laser that's in line, and the fact that they are so close, I would be fairly comfortable going with 0.14 kerf for both axes, and should be pretty close. Now you're going to need to play with that per material. It's going to have different burn rates, which might make it a little bit wider, a little bit thinner on each material. But for me on this one, that was a good starting point, and I was happy to see the results are fairly close to each other. Now these lasers can do more than just cut wood. We can obviously interact with other natural materials and some plastics. And so one of the popular plastics to use is extruded acrylic. Now with the diode wavelength at 455 nanometers, it's not going to interact with clear or some very lightly colored transparent or translucent materials. But if you get into the darker and the opaque materials, you definitely can cut them, and you'll have varying success with engraving them with or without a binder on top. So you can engrave clear as long as you maybe mark it or put some black paper on it, put some black paint on it. It's going to actually interact with that black paint, but you're not going to be able to cut those. But with some 3 millimeter black acrylic, I went ahead and ran some tests and was able to cut out these two little kitten keychains out of black acrylic. Basically just did the opposite engraving on each one, so you can kind of see the quality of the engraving. And these were done at the 48 watt setting. And so our beam's a little bit thicker and a little more aggressive. And so you got to do a little more playing. You could obviously drop this back down to the 24 watt setting, play with it a little bit, and maybe get some finer detail. But it's definitely feasible and possible to cut through black acrylic, maybe some of your darker colors, your reds and such. But as you get into the lighter colors, white and also blue, since it is a blue wavelength, it's going to struggle at those a little bit. So keep that in mind. Do a little bit of research on what colors are good for acrylics with diode lasers before you go buying this thinking you'll be able to cut all acrylics. However, it performed pretty well on my test with this one. Now, as I alluded to earlier, this laser does have a switchable head from 24 to 48 watts. And what that does is basically mechanically or electronically disable half the diodes in there, which cuts down on the amount of power being thrown at it, but also shrinks down the beam a little bit so that it's tighter, and in theory should give you better detail. And so that's a real spot where we're looking at for engraving, to allow this machine to have a high power 48 watts when cutting, get through that material quickly and efficiently, but when going to engraving, switching off half those diodes and allowing a little higher quality engraving. So it's not something you're going to want to necessarily do on the fly, but you would stop your job, run your cut job separately from your engraving job, and then manually flip that switch. But I wanted to take a look at its engraving ability, and I don't use this material a lot in lasers. It's just really smoky, and I don't necessarily like the way the fumes are, but I have some 1/8 inch MDF laying around, and so I ran that through for engraving because it is such a nice, smooth, and consistent surface. Anything I engrave on there should look a little bit better without worrying about wood grain and differences in heights. So I did go ahead and run engraving tests, and what you see over here is the 24 watt settings, and then at the same speeds and power rates, this is the 48 watt. And so you can see a pretty good difference there. It's obviously much darker on the 48 watt side than the 24 watt side. And we're getting really deep and really just almost blasting through the material here. But also up in these ranges here with the 24 watt, you'll see that even at 20%, we're really dropping off. There's really not anything of a marking there. So it's a little bit of a bounce there. Now, I only ran this from 5,000 up to 15,000 millimeters a minute. This machine is rated at up to 30,000 millimeters a minute, but in my experience, I've just found that those higher speeds really diminish things. And as you can see here in the 24 watt, we're starting to drop off at 15,000, not getting any marking in that 10 to 20% range. So to me, that means we're going to be really scaling it back below 15,000 for our engravings. So, and then of course, you know, we could run the 48 watt. I mean, if we're going for a solid engrave, maybe a vector engrave versus a raster and image style, maybe you want that depth, maybe you want that real dark look to it. Definitely an option. However, for the detail and without getting too deep and having still a nice gradient, I wanted to stick with the 24 watt setting for this test. So I went ahead and fired up Bing AI to pull me in a picture. I told it, make me a scene with a wolf in a pine forest. And well, it did. Came up with this picture that I'm putting up on the screen. Doesn't take long to bring that out. Just type your parameters and you can tell to do different things, add a moon, make it howl, things like this. And it'll give you some examples to play with. Well, I found one like this and went ahead and threw it into Lightburn. So we set it up with the Atkinson setting for dithering. I went ahead and put the head at 24 watts, 12,000 millimeters a minute, 90% max power, and this is how it came out. And so pretty good overall. I wish I could have played a little bit more with the minimum power, because what we're losing is there's a little bit of definition in the moon here where you can see some of the craters and the lakes there. And if I get in close, you might see that it's just barely kind of showing as being engraved there. I would have liked to see that come out more, but I really didn't want any of this to be darker. So, I mean, I could have increased my max power and that maybe increased that, but that's just something for me to play with in the settings and increase power. But overall, for the 24 watt laser settings, this came out pretty well. I'm very happy with that as far as an engraving. And this is just under 9 inches. I think it's about 8 3/4 inches in diameter. And so this took about 50 minutes on the laser to do that. I didn't see any skewing. So the motion is working well. It's holding its position and there's no really lines that are missing or overlapping. So that's just a testament, making sure that you get the machine set up right. But once you do, it's going to work pretty well. So that brings us to my whole purpose of why I'm interested in this laser and this wide format, and that is cutting balsa sheets for my model airplane hobby. Now, I would honestly love if this had just over 36 inches of working area. As it stands, it's about 32, just a bit under, and that kind of restricts me to the size. There are times I actually do cut parts out of 36 by 4 inch sheets of balsa, but this is opening up a lot more for me now. So what I have here is some 1/8 inch balsa wood. And this is real balsa wood. It's not some of the things I've seen labeled as balsa wood, which are more a mixture of plywood and basswood and such. I'm going to go ahead and set up a file that is going to have basically some sample parts on here. I've drawn up just a section of a wing. It's going to have a leading edge, a spar, trailing edge, and then we'll have our ribs and our ribs, and I'll mark them on there. So we're going to jump into Lightroom. We're going to take a look at that setup, and then we'll see how the laser cuts it out. All right, so I went ahead and cut did some test cuts on some balsa here. Again, this is 1/8 inch balsa, and I started down a little bit higher than the plywood, and as you see, we were just blasting through. So really worked my way up here to where it seemed like 4,000 and about 85% was going to be my sweet spot. So that was kind of the dial in for our cutting. And from there, you see I have another 4 squares here. This was so I could do another kerf test. Just wanted to see how this might burn a little bit different, if it might add a little bit of a thicker line. And I did come up with a little bit wider kerf on this. I'm running the 48 watt on here. And I'm going to be running a 0.2 millimeter kerf for this. That should hopefully give me a friction fit on the parts. Really don't want a lot of slop on these, but also looking for a nice clean edge. So here, if you can see it, is the edge of the balsa that I was cutting for those kerf tests. And you're just wanting that to be really caramelized, but not charred, because we are going to be gluing parts together. And so you don't want to have a lot of caramelization of the wood. You want that glue to be able to work into the fibers some. So, and again, I tested this again at the 4,000 millimeters a minute, 85% power. And then I did the engravings at 5,000 millimeters a minute and 25% power. And it's leaving a nice marking. It's not going too deep. We could actually probably back off the power and speed it up just a little bit, because those are fairly deep, and we don't want to deal with any extra burning or any sort of structural loss from actually cutting through. So let's jump over into Lightburn, and I'll show you what I'm going to be doing here. So what I have here are some wing ribs, and then I've used the lettering to label them all R1 because they're the same type of rib. And then I also have a leading edge, a trailing edge, and a spar. And so if you're not really familiar with what the airplane parts are, they are kind of, as they say, they're the leading edge of the wing, the trailing edge of the wing. And the spar is kind of the mid section, that's a vertical section that holds the wing together and gives it some vertical strength. So these parts should all interlock, and I have them set up to cut out. As you can see up here, we've got our 5,025. As I said, I'm going to bump this up. We'll take that to 6,500 millimeters a minute and try that. And the other thing I want to note on here is I'm using a tool line. So this is our orange line. That is the size of our 4 by 24 inch piece of balsa. So that's giving me kind of a reference point for laying out these parts, and I wanted to have them close but not touching. In this case, we're sharing that bottom line on these just to cut down on the amount of cutting to do. But then I also have used tabs. So if I was building this as a kit, I obviously don't want these pieces to fall out. I'd like the sheets to stay together so the person could build the parts and find them. So you can look at that tool. You need to turn off the beginner mode in Lightburn, and you can do that by going to edit and settings. And if this is checked, you're not going to see the tabs. So we've got it unchecked. So if I turn on the tab tool and come over to a part, you'll see that I have assigned some tabs, and what these are going to be little gaps in the material where the beam just cuts out for a little bit, just adds that little bit of tab. This will be really super easy to cut out with a hobby knife and or X-Acto blade. And so I want to make sure I have anchor points, at least 2 per piece in these inner pieces, and then I'm trying to find anchor points along the outside edges of these ribs and such so that they will stay tight. And I've done that on all the parts except for this one. So I'll show you. You can go in. So if you go into your layer, you turn on your tab generation. You can either do it automatic or manual. And so I am going to do that manual because I want to specifically point out where I want them. And then you set your tab size. So here we have it for 0.5 millimeter. I'm hoping that's just enough to just briefly interrupt that so that I can just nick that out of the way, but we will see. You could have it automatically space them every so often, but I like to put mine out there. So we've got that turned on. I'm going to come down here, and for these, I'm just going to simply alternate them. I don't want them like right next to each other, otherwise it could actually twist. This allows it to give some rigidity, and so I'm just going to go ahead and do that on each one of these, and then we will do the same on the outside parts as well in adding them, kind of staggering them here, 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 and here. Again, these are just to hold the parts in place. So once we have that set up, we're really good to go. If I was going to do a bunch of these, obviously I would set up kind of a jig or alignment tool in the laser, but we will just go with some framing for now. So let's jump over to the laser, get this dropped in, and see how it cuts out. All right, so the sheet cut out pretty well. I did have one that I apparently missed putting the tabs on, but as you can see, they're all being held in by these little tabs, which works well, but they also should pop out fairly easily. You can almost just twist some of these out, or you're gonna take your X-Acto blade, razor blade, hobby knife, and just trim out the parts, pop them free from the sheets. So especially working with balsa, that's a really nice method. So I'm going to go ahead and pop all these out. We'll check their fit and see about gluing them together. All right, and here we have it. One sample wing panel. It's nice being able to use that extra width. And the kerf worked out well. It was a little loose in some spots, so that could just be the material itself, or I'd have to double check the file. This is an older file. This isn't actually a real wing. It's a model I made to demonstrate lasers and CNCs and their ability to cut parts and interlocking design like this. So ideally, I wouldn't have had to use any glue. I did have to put a little bit on these ends because they were a little loose, and a couple of these spar to rib joints in the middle were a little bit loose, and that's not ideal with model aircraft. These are designed to be light. You don't want to add a lot of glue. You just want some glue to kind of interlock the fibers, maybe add a little bit of a fillet onto some joints, but you really want the structure to interlock to provide you the strength in being lightweight. But this machine is going to be really nice in being able to cut out parts like this. Like I said, I can use those 24-inch, or I even could squeak out a 30-inch sheet. Ideally, I'd love it if it was, had just over 36-inch working area, because that's about the widest I go on any of my sheets of balsa for this. But for model airplane parts or anything that needs that 24 to 30 some inch range, this is going to be a machine you might want to look at. It cut through this material really quickly, really cleanly, and left just a nice, very caramelized edge. So very happy with how this is going to perform in this aspect of both my hobbies. All right, this is where I think I'm going to leave this video, doing my initial tests and overview of what is possible with the Atomstack X40 Max. This is a very nice laser. I love that wide layout. I'm going to hopefully enjoy this in future projects, especially around my model aviation hobby. But if you have things like signs and cutouts that need to be a bit wider and you want to be able to do them in one piece, this may be a machine you want to look at. The 48 watt head that can switch down to 24 definitely has some nice capability between engraving and cutting, so it ticks a lot of the boxes. However, you are going to need to keep in mind this does take up more space. You are really going to want to be able to make an enclosure for it. There are a few on the market that might fit it. Otherwise, you're probably going to be like myself and be working on a larger do-it-yourself built up enclosure. So look forward to a video on that in the near future as I get this into a larger enclosure and use it more. If you want to find out more about this laser, I will have links down below. Some of them will be affiliate links, and those do provide a small kickback to me when you use them. And so I appreciate you using them. There's always no pressure. Once again, I want to thank you for stopping by. If this is your first time here, I hope you enjoyed it. Maybe hit that thumbs up. And if you want to see more, hit that subscribe button. If you have any questions, go ahead and leave a comment down below. Tell me what you think of this, maybe what you'd like to see me do, something maybe that you are curious about with this laser, and I'll try to get back to those as quickly as I can. Otherwise, thanks again for stopping by, checking this out. I hope you enjoyed it, or at least found it entertaining. But in the meantime, I hope you can get out into your workshop and make something too. We'll catch you next time.